question is asking us to calculate the theoretical yield of titanium in grams. Now, for us to get the theoretical yield, we need to understand what a theoretical yield is. So by definition, a theoretical yield is the amount of product that can be produced if all the limiting reagent reacts. So this then leads us to know what we need to do for us to calculate the amount of titanium that can be produced in grams. This is a limiting reagent problem. So we need first to identify which one of the reactants is a limiting reagent. How do you identify? We need to see which one can produce the least number of moles of titanium when we convert their masses into moles. So let's start with the first one, that is titanium 4 chloride, TiCl4. We know that number of moles is equal to mass divided by the mixture. So for TiCl4, we have 4 atoms of chlorine, and we have 35.5, and then we have 1 atom of titanium multiplied by 48. These are the relative atomic masses. So 4 multiplied by 35.5 gives us 142, and then 1 multiplied by 48 gives us 48. This, when you add 142 plus 48, is equal to 190 grams per mole. So the mixture we have is 190 grams per mole. Now that we have the mixture, we can calculate the number of moles using the mass that we have. So the number of moles is equal to, the mass we have is 354 grams, divided by the mixture, which is 190 grams per mole. So the number of moles will be equal to 354 divided by 190. It is giving us 1.86 moles of TiCl4. So these are the available number of moles when 354 grams is used. So at this point, we can use the mole ratio from the balanced equation to see the number of moles of titanium that can be produced. So the mole ratio is 1 mole of titanium chloride can produce 1 mole of titanium. So we have gotten the one here and the one here. So if you have 1.86 moles of titanium chloride, how much of titanium can be produced? So this is a cross multiplication that will take place there. Now, because this is a 1-to-1 mole, we are simply saying X will still be 1.86 moles of titanium. So when 1.86 moles of titanium chloride is used, 1.86 moles of titanium can be produced. So we can say for this one, we are saying 1.86 moles of titanium will be produced. Now that we have the number of moles that titanium chloride can produce, let's look at the number of moles that magnesium can produce. So let's analyze magnesium. Now, number of moles is equal to mass divided by, because magnesium is an atom, it's divided by the atomic mass. So the atomic mass for magnesium is 24 grams per mole. Now the mass we have been given, it is 113 grams divided by 24 grams per mole. So N is equal to, we are saying 113 divided by 24, it gives us 4.71 moles of magnesium. So we have the number of moles of magnesium that are available. We need to use the mole ratio to see the number of moles of titanium that can be produced if magnesium is the limiting reagent. So magnesium is saying when 2 moles of magnesium is used, 1 mole of titanium is produced. So we have used 2 to 1, which is here. So what of if 4.71 moles of Mg is used? What will be X? So this one is simply saying X is equal to 4.71 divided by 2. So what is 4.71 divided by 2? It is giving us 2.35. So these are the number of moles of titanium that can be produced. We have 2 number of moles. The number of moles that can be produced when titanium chloride is used is 1.86. Then the number of moles that can be produced when magnesium is used is 2.35. Remember, the limiting reagent is the one that gives us the smallest number of moles. So which of the 2 numbers is giving us the smallest? You would agree with me that this is the smallest number. Hence, we can say titanium 4 chloride is the limiting reagent. So now that we know the limiting reagent, we can use the number of moles for the limiting reagent to change them into grams. So we are saying the grams is the mass is equal to number of moles multiplied by, because this is an atom, we are saying multiplied by the atomic mass there. So the mass is the number of moles. We'll pick the number of moles that can be produced by a limiting reagent, which is 1.86 moles, multiplied by the relative atomic mass of titanium is 48 grams per mole. So when we have these 2 now, that is the number of moles and the relative atomic mass, we will just simply multiply them. We'll say 1.86 multiplied by 48. It is giving us, that is 89.28 grams of titanium. So these are the grams that can be produced, and we have found these grams by identifying that this is the limiting reagent.